Today we're going to be really focusing in on something, that's so fundamental to modern life, we practically take it for granted.
Yeah, it's like, we flip a switch and expect the lights to come on or plug in our devices without a second thought.
Exactly. We're diving into the U.S. grid infrastructure. And we're doing this for, the folks who are really interested in understanding how this massive system works, its current state, its future, but without needing an engineering degree to follow along.
Right. We want to make sure it's accessible to everyone, cut through the jargon and give you a clear picture of the health of the grid, the challenges it's facing, and the innovations that are reshaping it.
We're looking at a few key sources. The 2025 report card for America's infrastructure is a big one, gives us a really broad perspective. And then we've got some more focused data on stuff like the energy storage revolution, all the grid modernization efforts that are happening, and all the changes in how we're actually generating power.
Yeah, there's a lot going on in the energy world right now.
So our mission here is to first give you a good sense of the overall health of the grid, right? Where do things stand? Then we'll zoom in on the most critical areas where, we're seeing modernization and innovation, the stuff that's really changing the game.
And ultimately, we want to connect the dots for you, explain why this all matters, because it really does have a huge impact on the nation's economy and, on our daily lives.
Okay, so let's jump into it. First things first, paint us a picture of the U.S. grid right now. What's the big picture?
So the U.S. grid infrastructure, which includes the incredibly complex electric grid, is really the foundation of our economy and our way of life. It powers everything. And like you said, most of us don't really think about it until something goes wrong.
Yeah, you only really appreciate it when the lights flicker or you have a power outage. So then we've got the 2025 report card for America's infrastructure, which, is this expert assessment.
Right.
So what's the overall verdict? What are the main takeaways there?
Well, one thing that really jumps out is that the grade for U.S. infrastructure overall actually improved in this report card.
Oh, really? Interesting.
Yeah, it went from a C to a C, which, still isn't great, but it is a positive trend.
Yeah.
And they attribute that to, I'm quoting here, comprehensive support, innovative solutions, and bold leadership.
Okay, so a combination of factors, not just one silver bullet.
Exactly. And they also point out that almost half of the 18 infrastructure categories they assessed actually saw their grades go up.
So that's encouraging, but a C still suggests there's a lot of room for improvement, right? What are some of the things dragging that grade down even with the progress?
Yeah, there are definitely ongoing concerns. The report really stresses the importance of sustained investment in infrastructure. And not just planning. They emphasize actually getting projects built, actually completing them. Because even with some of the upgrades, there's this persistent vulnerability. Our systems are aging, and they're increasingly at risk from natural disasters and extreme weather. And, that poses a big threat to public safety and to the economy. Just think about all the storms and wildfires we've seen lately. They're putting a lot of stress on the system.
Yeah, no kidding. And, we hear a lot about the IIJA and all the federal funding going into infrastructure. So is that starting to have an impact?
The IIJA, the Infrastructure Investment and Jobs Act, is definitely a positive development. All that federal and state funding is starting to make a difference. But we have to remember that these projects, they take time. You can't just snap your fingers and have a brand new grid.
Right, so it's a long-term investment.
Exactly. It's a long game. You have to do all the studies, the designs, and then the actual construction. It takes years to see the full effects.
And the report, it also mentions this history of underinvestment in the grid, right? Maybe we're playing catch-up now because we didn't invest enough for a while.
You hit the nail on the head. We've had this problem for decades, where the level of investment in infrastructure just hasn't kept pace with the growing demands on it. And that's created this huge backlog of upgrades and replacements that we're dealing with now.
Oh, so we're trying to make up for lost time now. And for those of us who don't spend all day thinking about infrastructure grades, can you break down how the ASCE, the American Society of Civil Engineers, how do they actually come up with these grades? What factors are they considering?
So the ASCE, they do this assessment every 4 years, and they use this A to F grading system. Pretty straightforward. And they're looking at 5 key areas. So first, there's capacity, meaning can the infrastructure handle current and future needs?
Makes sense. Is it big enough?
Yeah, then there's condition, is it in good repair? Then, of course, funding, how much money is going into it? Future needs, are we planning for what's coming down the road? And finally, operation and maintenance. How well are we taking care of the stuff we have?
Okay, so it's like a pretty comprehensive look at the whole system.
Exactly. They're trying to get a complete picture of how well the infrastructure is performing now and how it's going to hold up in the future.
Got it. So, some good news, some bad news. The grid is getting better, but there are still some major challenges ahead. So let's dive into one of the key areas for tackling those challenges, which is grid modernization. Why is that such a big deal right now?
Grid modernization is crucial because we're seeing this massive shift towards electrification across all sectors of the economy. And that's driving up energy demand like crazy. It's the biggest increase we've seen in 2 decades.
Wow. So what's behind that surge in demand? What's using all this electricity?
2 big factors are, first, the explosion of electric vehicles. More and more people are driving EVs, and that takes a lot of power. And then, of course, there are the data centers, all those massive server farms that power the internet and everything we do online.
Yeah, they're like power-hungry monsters, so we need more power, and we need to get that power to where it's needed, right?
Absolutely. And to connect all the new renewable energy sources, the solar farms, the wind farms, especially those that are being built in remote areas where the resources are best, we have to seriously upgrade the transmission capacity. Think of it like this. We need to build a whole new set of highways just to handle all the extra traffic.
Makes sense. And so the IIJA and the IRA, those are supposed to help with this, right? To get all this modernization done.
Both of those pieces of legislation, the IIJA and the Inflation Reduction Act, are providing a lot of financial support to develop and deploy renewable energy and to make the grid more resilient.
Yeah.
What they call grid hardening.
Okay, that's good to hear. But isn't it also tricky to actually get all these new energy projects connected to the grid? I feel like I've heard about delays and stuff.
You're right. There's a big backlog of applications from new generation and energy storage projects that are waiting for approval to connect to the grid. And right now, the average wait time is about 35 months. That's almost 3 years. So, yeah, that's a major obstacle.
Wow, that's a really long time to wait. I mean, that has to be slowing things down. Are there any efforts to, fix that bottleneck?
FERC, the Federal Energy Regulatory Commission, did adopt some interconnection reforms last year. They're supposed to streamline and speed up the process.
Okay, so there are some changes happening.
Yeah, but these reforms are still pretty new. They haven't been implemented in most regions yet. So, for now, those delays are still a big challenge.
So it sounds like it's going to take a while for those reforms to really kick in.
Yeah, exactly.
Okay, so, aside from just connecting new stuff, what about making the existing grid tougher, more reliable, especially with all the crazy weather we've been seeing?
There's a big push for that. It's to build more resilient transmission and distribution networks. That means using stronger materials, better designs, and really focusing on what they call hardening.
Okay, so making it tougher to knock out.
Exactly. So, things like burying power lines underground to protect them from wind and falling trees, using fire-resistant materials, replacing old weak poles with stronger ones, just making it less vulnerable to damage.
Yeah, that makes a lot of sense. And what about these smart grids we hear so much about? What are those exactly, and how do they fit into all of this?
Smart grids are all about using digital technology to make the grid, smarter. It's like adding a layer of intelligence to the system. So you get better monitoring, more control, and it just operates more efficiently overall. One of the big benefits is that you can identify problems in real time and respond to them much faster.
Okay, so it can kind of fix itself?
Well, not exactly fix itself, but it can react much quicker. Imagine the grid being able to sense a problem and then automatically reroute power to avoid a bigger outage. That's the kind of thing smart grids can do.
That's pretty impressive. And the GRIP program, how does that fit into this whole modernization push?
Right. The Grid Resilience and Innovation Partnerships Program. It's funded through the IIJA. And it's specifically designed to support projects that are testing out these new approaches to grid hardening and resilience. And a lot of them do involve smart grid technologies.
So it's kind of like the testing ground for the future of the grid.
Yeah, exactly. They're trying to figure out what works and what doesn't.
Okay, that's really interesting. Now let's shift gears a bit and talk about energy storage. It seems like everybody's talking about batteries these days. So why is energy storage so crucial for the grid, especially as we move towards more renewable energy?
Well, energy storage is becoming absolutely essential because it helps us deal with the variability of renewable energy. Solar power only works when the sun is shining, and wind power needs wind.
Right, so they're not always producing power consistently.
Exactly. And that's where storage comes in. It's like a buffer. You can store energy when there's a surplus and then release it when you need it.
Okay, so it smooths out the bumps in the supply.
Exactly. And it has all kinds of applications. From those giant battery installations connected to the grid to the batteries in electric vehicles.
Yeah.
And the economics of storage are really evolving too. There are all these new business models emerging where operators can buy electricity when it's cheap and sell it when it's expensive.
Oh, so they can, like, play the market a bit?
Yeah, they call it price arbitrage. And often they'll combine that with other services to maximize their profits.
Okay, so it's not just about storing energy, it's about using it strategically.
Exactly.
And on a global scale, how big is energy storage? Is it still a niche thing or is it really taking off?
Oh, it's definitely taking off. We're seeing this huge global push for energy storage. Governments are setting ambitious targets, offering incentives, and that's driving investment.
Okay, so it's a global trend.
Absolutely. By the end of 2023, global storage capacity had reached an impressive 276 gigawatts.
That's a massive amount.
Yeah, it is. And that includes all kinds of technologies. But the two biggest are pumped hydro storage, which makes up the bulk of it, and then lithium-ion batteries.
Oh,
Yeah,
really?
pumped hydro is kind of the old reliable. It's been around for a while, and it's really good for grid-scale storage. But lithium-ion, that's what you see in electric vehicles and consumer electronics, and it's getting cheaper and more efficient all the time.
So different technologies for different purposes?
Right. Each technology has its own strengths. And there are a bunch of other technologies in development too, so the field is evolving rapidly.
Exciting times for battery nerds. But what does all this storage actually do for the grid? Like, what are the concrete benefits for, regular people?
Well, there are at least four main categories of benefits. So first, you have what they call ancillary services. These are really important for keeping the grid stable and balanced, like responding to sudden changes in supply or demand.
So it's like a safety net.
Yeah, exactly. Then there are energy and capacity services. Storage can act like a power plant, essentially. It can provide electricity when it's most needed. And then there are transmission and distribution services, where storage can actually help to optimize the flow of power on the grid and even reduce congestion on transmission lines.
Oh, so it can prevent those bottlenecks.
Exactly. And that can save a lot of money because it means we might not have to build as many new transmission lines. And finally, there are customer-level services, things like providing backup power to homes and businesses during outages.
Okay, so storage is like a multi-tool for the grid.
Right, it can do a lot of different things.
And what about the environmental impact of all this? I mean, batteries aren't exactly known for being super green.
You're right, the environmental impact really depends on the specific technology. The materials that go into it, the energy used to manufacture it, and how it's disposed of or recycled at the end of its life. But some technologies, like closed-loop pumped hydro storage, have a pretty low greenhouse gas footprint.
Okay, so it's not all created equal.
Right, and that's why research and development into new storage technologies is so important. We need to find the most sustainable options.
Makes sense. And speaking of policy, how is the Inflation Reduction Act affecting all of this? Is it having an impact on energy storage?
Definitely. The IRA has made grid-scale energy storage much more attractive financially. It offers this investment tax credit specifically for standalone storage projects, which is a big deal. And it also includes provisions to support domestic manufacturing of these technologies.
Okay, so it's like a boost for the whole industry.
Yeah, exactly. It's creating a lot of excitement in the energy storage world.
That's great to hear. Now, as we shift more towards renewables, we need to talk about stability. Like, how do we keep the lights on when we're not relying on those big traditional power plants as much?
That's the million-dollar question, right? It's a big challenge because with fossil fuel plants, you can pretty much control the output. But renewables, they depend on the weather. So you need ways to manage those fluctuations.
Right, so when the wind stops blowing or the sun goes down, what happens?
That's where storage comes in again. It's essential for smoothing out those variations. You store energy when the sun is shining or the wind is blowing, and then release it when you need it.
And you mentioned earlier those e-methanol plants. Are those like another tool for dealing with the variability of renewables?
Yeah, those are pretty cool. They can adjust their output based on the grid's needs, so it's another layer of flexibility.
So it sounds like the future grid will need a mix of different technologies working together.
Exactly. We need a diverse portfolio.
Yeah.
Renewables, storage, and potentially other things like hydrogen storage.
And we've talked about smart grids and AI, artificial intelligence. How does AI actually help with all of this?
AI is really good at analyzing tons of data. in real time. It can look at energy production from all the different sources, consumer demand patterns, even the status of the grid infrastructure itself. And based on that, it can predict problems and even take action to prevent them.
Okay, so it's like having a really smart operator who never sleeps.
Exactly. It can do things like, optimize how power is distributed, forecast energy loads, reroute power during outages, and even detect cyber attacks.
Wow, so AI is like a game changer for grid management.
It has the potential to be, yeah. It can make the grid more reliable, more efficient, and more secure.
And what about microgrids? I feel like they're getting a lot of buzz lately.
Microgrids are interesting. They're these localized energy
Everything's
networks,
powered by
kind
the
of like
solar
mini
panel.
grids.
Or two of the
And they're
solar
really
panels.
good for increasing resilience, especially during extreme weather. Because if the main grid goes down, a microgrid can keep operating independently.
Oh, so it's like having a backup power system.
Yeah, sort of. They're not widespread yet, but they're becoming more and more popular, especially for critical facilities like hospitals and data centers.
Okay, so they're kind of like an insurance policy against big outages.
Exactly.
Okay, let's switch gears again and talk about, where all this electricity actually comes from. What's the mix of power generation sources in the U.S. right now?
So the U.S. has this mix of traditional sources, fossil fuels like natural gas, petroleum, and coal. And then there's nuclear power, and of course renewables like solar, wind, and hydro.
And I feel like we're seeing this big shift towards renewables, right?
Definitely. Renewables are growing really fast, especially solar. We're seeing a ton of new solar capacity being added every year.
That's awesome.
Yeah.
But is natural gas still the main player for now?
Yeah, natural gas is still a big part of the mix. It's reliable, and it's relatively clean compared to coal.
Okay. And again, this highlights the importance of energy storage, right? To make sure we have power when the sun isn't shining or the wind isn't blowing.
Exactly. We need that flexibility to make renewables work on a large scale.
And it's amazing how much cheaper renewables have become, right? Like, wasn't solar power super expensive not that long ago?
It was, but the cost has come down dramatically in recent years. It's incredible. In many parts of the country, solar is now the cheapest way to generate electricity.
Wow, that's a game changer.
It really is. And it's one of the main reasons why we're seeing this rapid transition to clean energy.
And there's even talk about going 100% renewable by 2030, right?
Yeah.
Like powering the whole country with just solar, wind, and batteries. Is that even realistic?
It's definitely a bold goal, but some studies suggest it is technically feasible. They call it an SWB system, solar, wind, and batteries.
Mm-hmm.
And the costs are coming down so fast that it might even be affordable.
Wow, that would be
It
amazing.
would be a huge achievement. But it would also require massive investments in new infrastructure and some really smart planning to make sure we can manage the intermittency of renewables.
Right, so we need to make sure the lights stay on even when the sun goes down.
Exactly. It's a big challenge, but it's definitely an exciting goal to strive for.
Absolutely. Okay, let's talk about the infrastructure that carries all this power around.
Yeah.
The transmission and distribution system, all those power lines we see everywhere. What shape are those in?
So the U.S. transmission and distribution system is huge. You're talking about hundreds of thousands of miles of high-voltage transmission lines and millions of miles of distribution lines that connect to our homes and businesses.
Wow, that's mind-boggling.
It is. And a lot of this infrastructure is getting old. Some of it is 25 years old or even older. And in recent years, we've been losing about 5% of the electricity we generate just during transmission and distribution.
5%? That's a lot of wasted energy.
It is. And it shows you why we need to invest in modernizing the grid. We're
Yeah.
losing a lot of power just because of outdated equipment.
Yeah, that's not good. And I know there's a big push to build more transmission lines, right?
There is. They're projecting that we'll need over 28,000 miles of new transmission lines over the next 10 years.
Wow, that's a lot of new lines.
It is. And it's mostly to connect all the new renewable energy projects that are coming online. We need to get that power to where it's needed.
And this is another area where the IIJA is providing funding, right?
Exactly. The IIJA has a lot of money dedicated to grid modernization, including building new transmission lines, and they're also focused on making the grid more resilient to extreme weather.
Okay, good. But we're still facing those delays in getting new projects connected to the grid, aren't we?
Unfortunately, yes, that's still a major bottleneck, and it's slowing down the whole transition to clean energy.
So what can we do about that?
Well, there are some ideas being explored, like co-locating energy storage with renewable generation projects that can help to maximize the use of the existing grid connections.
Oh, okay. So it's like getting more bang for your buck with the infrastructure you already have.
Exactly.
Now, we've talked about AI and how it can help with grid stability, but what other roles can it play in managing this whole system?
Well, AI is really good at analyzing data, right? And the grid generates mountains of data every second. So AI can help us make sense of all that information and use it to operate the grid more efficiently.
So it's like having a super smart assistant for the grid operators.
Yeah, think of it that way. AI can help to identify potential risks, optimize energy flows, predict demand, and even automate responses to problems.
Okay, so it's like taking grid management to a whole new level.
Exactly. It can help us to improve reliability, reduce outages, and integrate renewables more seamlessly.
That's really cool. And one last thing I wanted to touch on. All of this requires a workforce, right? People to build and maintain all this new technology. So what's happening on that front?
That's a really important point. The clean energy transition is creating a huge demand for skilled workers. We need people to install solar panels, build wind turbines, operate energy storage systems, and so on.
Yeah, these aren't jobs that can just be automated away.
Right. And we're already seeing a lot of job growth in the energy sector. Utilities are hiring like crazy, and there are all these new companies popping up.
So it's a good time to be in the energy business.
It is, especially if you have the right skills.
Yeah.
And policies like the IRA are helping to create even more jobs by incentivizing domestic manufacturing of clean energy technologies.
Okay, so there are a lot of opportunities out there. Well, we've covered a lot of ground here. It sounds like the U.S. grid is going through some really major changes, and there are both challenges and opportunities ahead.
Absolutely. As we saw in the infrastructure report card, the grid is getting better, but there's still a lot of work to do. Modernization is key. We need to invest in new technologies, upgrade our aging infrastructure, and make sure we have the workforce to support all of this.
Yeah, it's a complex system, but it's also incredibly important. It powers our lives.
It does. And the choices we make now will have a huge impact on the future of the grid and on our ability to transition to a cleaner, more sustainable energy system.
Well said. And I think that brings us to our closing thought for today. We've talked about all these ambitious goals for renewable energy and the challenges of modernizing the grid. So for you, our listener, the question is this. What do you think is the biggest obstacle we face in building a truly reliable, affordable, and sustainable power grid for the future?
It's a big question, and there's no easy answer. But it's something we all need to think about because the future of energy is in our hands.
Absolutely. Thanks for joining us on The Deep Dive. We'll see you next time.
Santa Clara, where we visited Vantage, has long been one of the nation's hotspots for clusters of data centers near data-hungry clients. NVIDIA's headquarters was visible from the roof. Now, Vantage is building in places like Columbus, Ohio, and Atlanta, Georgia.
In Northern California, we're seeing a bit of a slowdown in terms of where data centers are deployed because of the lack of availability of power from the utilities here in this area.
On the flip side of bringing data centers where the power is, some AI companies and data centers are experimenting with ways to generate their own power right on site. OpenAI CEO Sam Altman has been vocal about this need. He recently invested in a solar startup that makes shipping container-sized modules that include both the panels and power storage in one. Altman's also invested in nuclear fission startup Oklo that aims to make mini nuclear reactors housed in A-frame structures, and in nuclear fusion startup Helion. Microsoft also signed a deal with Helion last year to start buying its fusion electricity in 2028. And Google's partnered with a geothermal startup that says its next plant will harness enough power from deep underground to run a large data center. Even data centers themselves are starting to generate their own power.
Which Vantage has done, for example, in Virginia, where over the course of the last year we deployed a 100 megawatt natural gas power plant to support a dedicated data center for one of our customers there.
At the same time, to integrate in the best way possible all these renewables, we need to increase storage, being pumped hydro batteries and all other forms of storage. So in a way, how consumer choices and government policy will play out will have huge consequences, and we still have very much the keys towards going to a much more secure and climate-friendly future.
And you see for the battery metals, which lithium, nickel, cobalt, and graphite, you have in some cases some quite impressive growth in supply over the next decade or so. It isn't the case for copper, declining ore quality, not a lot of new projects coming through there. And what this means is that with the rapid expansion of demand, there are some important gaps there between our demand net of recycling and the anticipated supply that we see coming through from different projects.